What's up, my dudes? This is my project here. Yeah, let's go get this bread.
Cesium.
These are the two people that discovered my beautiful element, Robert Bunsen and Gustav Kirchhoff. Cesium is the heaviest of the stable alkali metal elements, which means it has more electron shells than any other group 1 metal. Alright, so legends. Fun fact for today. I had no idea about this, but as you can see, cesium is used to help drill oil and make vacuum tubes. The most common everyday use for cesium is with the GPS on a cell phone. That's awesome. Cesium clocks is the more accurate term for atomic clocks. I don't even know what those are, to be honest, since cesium is used in the clocks. Great. Another fun fact. It is a rare element present in the Earth's crust at around 3 parts per million. It was the first element ever to be discovered using the newly created spectroscope. Another fun fact here, cesium immediately explodes in water. How crazy is that? Adding on to this wonderful information, it reacts extremely rapidly with water to generate cesium hydroxide and hydrogen gas.
Now, let's proceed to the most interesting part, conducting experiments with cesium. Firstly, to get the cesium out of the vial, I decided to melt it in the vial, and then pour out the liquid cesium in kerosene. However, something went wrong during that part. The liquid cesium instantly ignited in air, burning everything around it. That happened most likely due to the fact that the cesium in the vial was liquid. A water hammer happened, and the top of the vial broke off, pouring cesium onto the table. You can see what happened next. The table is now out of use, but that's okay, we still have more tables. For further experiments, we had to buy another vial of cesium. Now I decided to do things differently, breaking the end of the ampule with a solid cesium, and then heating kerosene. This all turned out well. Gradually the liquid cesium began to flow from the vial into the kerosene, after which it immediately lost its golden shine and got covered with a layer of oxides and peroxides due to the impurity of water and oxygen in kerosene. We have decided to destroy the vial with the remnants of liquid cesium by throwing it onto the wet wall. After solidifying, the cesium can be easily cut, even with a spatula, and it is not just the most active but also the softest metal in the world, that resembles margarine for its softness. For the first time on YouTube, you can now observe cesium as being cut. First, I took a piece of cesium and put it on a piece of wood. Cesium melts from the oxidation reaction of oxygen in the air, and then self-ignites with a beautiful magenta flame due to cesium ions. Cesium also behaves similarly on the napkin. Furthermore, by analogy with rubidium, I decided to conduct the reaction of cesium with sand, igniting cesium on sand. Similarly to rubidium, cesium reacts with the silica, which the sand consists of, very calmly and forms a beautiful shiny surface, and also an amorphous silicon. Next I decided to learn how cesium reacts with manganese sulfate. The response wasn't very rough, but it is better that it was with sand, when it's formed a metal manganese. The coolest reaction by far was cesium with sulfur, when we trap the pieces of cesium in molten sulfur. In that reaction, the two elements formed cesium sulfide.